So dear students, in the last class I have discussed about force. What is force? Okay, we have discussed in the last class. Now actually we are going to talk about Newton's laws, and before discussing Newton's law we need to understand about what is inertia, obviously. So in this class basically we will discuss about what is inertia. Okay, so let me see one by one. So as I have said earlier that the first law of motion, which is also called the law of inertia, so you need to understand about inertia obviously, and to learn about inertia first obviously. So what is actually inertia? So let me take some examples to understand what is inertia. So first you can see in your daily life you have experienced that if a object is at rest, so it will continue to be at rest, and if the object is moving it will continue to do so. And you can see that if the net external force is zero on any object, if the net external force is zero, then what will happen? First, the body which is at rest will continue to remain at rest, and an object which is in motion will continue to move with a uniform velocity. Okay, so here I can point out this thing also, that tell you one thing. The term that here is arise first actually, that is uniform velocity. Okay, so this is very important term here. Uniform velocity means this velocity is a vector quantity. So here uniform velocity means v vector, and v vector means it has magnitude as well as direction. Okay, so any vector quantity had magnitude as well as direction. So if you talk about the uniform velocity, that means v is equal to constant. V is equal to constant, and v is equal to constant means its magnitude constant and direction also constant. So if a object is moving in a straight line, then it will continue to do so if the external force is zero, if there is no external force. Okay, and if an object is at rest, then obviously it will remain at rest. Okay, so this property due to which a object is want to persist its states, its initial state, the state of motion, you can say maybe it is rest or maybe it is in motion. So the virtue of which a object wants to persist its this state of motion, this property is actually called the inertia. Okay, this property is actually called inertia. Okay, and now you can tell this inertia in another way also, that it is just a resistance. Okay, inertia means a resistance to change. Okay, suppose if you know, maybe you have heard this term resistance in electricity chapter in your earlier classes, but resistance means actually the something opposing thing. Okay, resistance means opposites actually. So if you know that in electrical circuit there is a resistance due to the collision in the crystal, the resistance offered by the crystal to the electrons actually. So in a circuit, in a circuit, suppose there is a conductor, and inside the conductor the electrons are moving, and these electrons face opposing force due to the collision, and that opposing force, due to this opposing force, there is a property of this conductor, and that is called the resistance. Okay, so resistance means something opposing thing. Okay, so inertia also means the resistance to change, and here this resistance is nothing but due to its mass. Okay, so the object will persist its, the objects want to persist its state, and it remains in state of motion, or wants to remain its state of motion or its state of rest. If the object has a large mass, then it is difficult to change its states. Okay, to change its state of motion. So that's why you can say this inertia is also the resistance to change. Okay, so let me take for this also example, that a ball at rest stay at rest unless acted upon by a force. And in your daily life you can see many things that they are at rest because there is no force to give them motion. Okay, so inertia is basically the equivalent to mass. Large mass, which object has large mass, and that object has large inertia. Okay, so mass is actually the measurement of inertia. Okay, so inertia is a property of an object, and if you want to measure this property, then you have to take a physical quantity, and that physical quantity obviously the mass is the measurable quantity, and this measurable quantity of inertia is mass. Okay, and if the mass of the object is high, then obviously the resistance is high to move the object or to stop the object. So if the object is moving of the high mass object, there is a large inertia. If the object has a large inertia and the object is moving, then you know to stop the object a huge amount of force is needed. Okay, so it is more resistance to change its states. Similarly, object which have a large mass, there is also the huge amount of force is needed to move the object. So there is also a resistance to change its state of motion. So inertia means resistance to change, and change means here the state of motion, change of state of motion. Okay, so inertia is actually the mass is actually the measurement of inertia. Okay, so mathematically you can measure this inertia by the estimation of mass. Okay, and you can see this football. So this ball is at rest, and you can say this is at in a stable equilibrium, or it is in a unstable position. Okay, now if you want to move it, you have to give it force. So if you give this ball force, then it will move obviously. Okay, so you can see that this motion can be created, and the ball can be the ball can move if you give force on it. Okay, so and this is actually the inertia. Now let me conclude this thing, that what is inertia. So I can give another example, obviously, that here also the mass is very large than the ball. Okay, so if you want to move a ball, then a little amount of force is needed. But if you want to move this sofa, then obviously you have a large amount of force is needed, and sometimes a person alone cannot move this sofa. Okay, so if this man is trying to push this sofa to move, but obviously if the inertia of this sofa is so large that he will fail to move this object. Okay, so you can understand from these examples that the mass is responsible for this resistance to move. Okay, so he can't move because it's large in size, and large in size means obviously its mass is huge. Okay, so things like to stay as they are, obviously, due to its inertia or due to its mass, and it is not willing to move. And this is the property of, or the tendency to not willing to move is known as, in our daily life use word, we use the word laziness, or something called lazy. Okay, so in our daily life we use the word lazy. Okay, and all things in the universe are lazy, you and me, not the non-living things, but the living things also are very lazy. We all are lazy. If there is no external force, we don't want to do any work. Okay, so this, from your daily life experience, that we all are actually lazy, and all things in the universe are lazy, and you can't move without external force. Okay, and if you do not have any coaching class, or something, any work, then you don't want to wake up at very early morning because of your laziness. This is nothing but due to your inertia. So all things in the universe are lazy. Okay, and to move the things, you have to push, it, or you have to pull it. Okay, so no object in this world starts moving on its own, obviously. So if things are lazy and they don't want to move, how does the movement happen? Obviously by using the force. So you can see, if you want to give force, and if you want to move the ball, then you have to push it. Okay, and a huge amount of effort needed, you can see. Okay, to move this ball. Okay, even the ball is very small, you can see how much effort the person have to be done to move this ball. Okay, so the laziness is a factor that need force actually to move. Okay, so push and pull are the things which make the objects move and change their position, obviously. If we want to change the position of an object, an external force is needed. I have already discussed this thing. Okay. And if force is not acting on the ball will not stop and it keeps on moving and moving. And this is very important and statement, and that will move us to the Newton's first law actually, that if force is not acting on the ball will not stop and it keeps on moving and moving. Okay. When a ball is kicked in space, it keeps on moving without stopping. But in our atmosphere, it stops. We see that according to this statement, if you see this statement, if you see this statement and this statement, okay, here what is saying that if force is not acting on the ball is not stop and it keeps on moving and moving. But in our real life experience, we have seen that if you kicked a ball in space, it keeps on moving without stopping. It should keeps on moving without stopping according to this statement. But actually, in our atmosphere, it stops because of some resistance. Okay, because of some resistance, air resistance, roughness of the ground, and certain obstacle coming in its path. So there is an external force that leads the ball to stop. Okay, if there is no external force, then when you will kick the ball will never stop. Okay, because it is laziness, because it's inertia, it wants to persist, it wants to remain its state of motion. But if there is a air resistance, there is a roughness of the ground and certain obstacle coming in its path, then obviously the ball have to be stopped due to this external force. Okay, so things want to stay in the same position as they are. Okay, either it is in the state of motion or it is in the state of rest. Okay, and things want to keep doing what they are already doing, obviously same thing that so how can you say things are lazy, and what you will give the name of this laziness? Physicists have the special name for this laziness, and that is inertia, obviously. Okay, so inertia means actually laziness, and the measurement of inertia is nothing but mass. Okay, so if things are at rest, then they want to stay in rest, and if things are in motion, then they want to move on and on. Okay, so and this is obviously Newton's first law of motion. We have already reached to the Newton's first law of motion with these examples, and you can now arrange these examples in a compact manner, in a compact fashion, and that's the statement of Newton's law. And it states that every body continues its state of rest or its state of motion until and unless an external force is applied. Every body continues its states of rest or its state of motion until and unless external force is applied. This is the statement of Newton's first law that we have already discussed through the examples, and we have reached this statement automatically with the examples. Okay, so now let me do one or two MCQ so that you can understand what we have studied. So what is inertia? Option A, it is a property of a body to oppose change in its state of rest or motion and vice versa. It is the property of a body to change from rest. It is a property of a body to change from motion. None of the above. Obviously option A is correct. Obviously option A is correct because it is not only the property of a body to change from rest or change from motion, but both. So it is a property of a body to oppose change in its state of rest or motion and vice versa. Obviously. Okay, and you can see from this definition that here it's saying that a body at rest continues to remain at rest, and a body in motion continues to move with uniform velocity. So option A is correct, obviously. Okay, now which of the following is also called the law of inertia? Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and none of the above. And obviously option A is correct, and we have seen earlier that the first law of motion is also called the law of inertia. Okay, thank you.